Data-centric applications are applications where data is at the core of its design. We created a framework that allows to create observation relationships by using a data-centric approach. What is observation and why is it important? Let's explain with an example. Let's imagine a user, here shown as Tom, wants to go on a shopping spree. Before shopping, Tom looks at his bank account to see how much money he has and sees that he has 1,500 euros available. Tom also has a credit card that is linked to his bank account that he can use to pay for his items. With the knowledge that he has some money on his account, Tom goes shopping. First, Tom buys a bike for 500 euros, and since he had 1,500 euros available earlier, he continues shopping. Then, Tom buys a new smartphone for 800 euros. Satisfied with his shopping, Tom goes home. At home, Tom checks his bank account to see how much money he has left. Shockingly, Tom sees that his balance is currently negative and becomes upset. How could this have happened? What Tom forgot was that today his mortgage would be withdrawn from his bank account. And since Tom didn't check his bank account during shopping, he didn't see that he didn't have enough money left for all his purchases. With observation, that wouldn't have happened. Observation means that Tom can tell his bank clerk that he wants to get notified every time his account is charged, for example, through a message to his phone. And this act of wanting to get notified is an observation relationship between an observer, in our case Tom, that wants to get notified, and an observable, his bank account, that needs to send notifications every time its state changes. Now with observation, every time money is withdrawn from his bank account, he receives a notification with his current balance. So if Tom buys a camera for 300 euros, his bank account is charged 300 euros, and then Tom receives a notification with his current balance, since the state of his bank account changed. Thus, he doesn't need to fear any unpleasant surprises in the future anymore. Another important aspect of this framework, apart from providing tools to create observation relationships, is that it is model-driven. Typically, in order to create an application, the developer has to write code. This has some disadvantages. Code can be hard to read, and it is difficult to explain how an application works by showing its code. However, there are different approaches to programming. One such different approach is model-driven engineering. With model-driven engineering, instead of writing code, the developer creates models. This means he creates a representation of what he wants the application to do, instead of worrying on how the application is going to work, or on how to write the code for the application. This provides some advantages. Models tend to be easier to reuse. A further advantage is that models tend to be easier to understand than code. This allows the developer to more easily develop the application with other stakeholders that might have no coding knowledge, and allows them to involve those stakeholders further in the development process. After creating the model, the code for the application is then generated using a generator. A generator is a tool that reads the created models and translates them into code, so that we have a running application at the end. In this thesis, the MontyGem generator is used. Applications created by MontyGem follow a data-centric architecture. And this is what this thesis provides. We provide tools that allow to model the observation relationship and adapted MontyGem so that it understands the models and generates the appropriate code to allow for observations between elements of the application. Further features that the observation framework provides and details on how this was achieved can be found in the Master Thesis Observation Framework for Data-Centric Applications.